Okay, everyone, in the WebEx control panel, you'll see 5 questions under the poll questions area, and it'd be great if you would answer all 5 of the questions. They're just some questions so we can gather some information about you and your background in programming. And the first question is, which tool do you primarily use for application development? Primarily. The second question is, if you're using an Embarcadero tool, like C++ Builder or RAD Studio, are you using the XE2 version? The third question is, where did you hear about this webinar? And there's a few choices there. And then the fourth question is a multi-select question. It says, what desktop platforms do you build applications for? And the fifth question is, what server platforms do you build applications for? So if you build server-side applications, what are they running on? Windows, Linux, Unix, or some other system? And if you're building desktop applications, is it Windows, Mac, Linux, or other? So we'll just give you a few seconds to answer those questions and the polling. You can do that anytime, and then TechExtend and Sarah will shut off the poll at some point in time as well. So just take a few seconds to click on those 5 questions. Again, number 4 and 5 are multi-select, but you can just select one if that's the choice in those as well. The other ones are single choice. And again, welcome to this webinar, which is all about creating Windows and Macintosh applications from a single C++ code base with our C++ Builder XE2 product. And so in this webinar, you'll learn how to create native applications for Windows and Macintosh using your C++ skills. And if you're doing Windows only, this will allow you to support the Macintosh and to support, if you're building software, to have more users to sell your applications to, or inside your company, more desktops or more more Macintosh and Windows desktops when you're building Macintosh applications. And why Windows and Mac? Well, because number one, Windows, of course, is the leading desktop platform, but Macintosh sales are growing larger than any other segment. Apple's now 3rd in the PC market in the U.S. alone, but it's happening all over the world. It's happening in China and France and the U.K. and elsewhere. And also, if you're thinking about moving some of your applications to iOS, then the Macintosh is an on-ramp to getting to iPhones, iPads, and so on. Forrester Research has said for some time the Macintosh wasn't welcome in the infrastructure of IT and enterprises, but now Forrester is encouraging companies to support Apple hardware in the workplace. Again, there's more than 60 million Mac users, so if you're an ISV, this means more users to sell your software to. If you're a consultant, more consulting gigs on Windows and Macintosh. And if Macs are getting into your enterprise in your company, then you can build applications for the Macintoshes as well. Now, some people say, why not multiple tools? Why not use Visual Studio and then use Xcode on the Macintosh? Well, it's 2 sets of code, 2 sets of projects, 2 different build systems, 2 different IDEs. And when you're running, you're going to have to do things specific to each platform. With one tool, you only have to develop your application one time and recompile and rebuild and redeploy it to Windows and Macintosh. And that's what I'm going to show you how easy it is in C++ Builder XE today. Now, we have a lot of new technology in C Builder XE2. First, of course, we have enhanced Windows support, but we've also added the Macintosh. We have our new business application platform called FireMonkey. It allows you to build high-definition and 3D applications that run on Windows and Macintosh. We've added new tooling to the IDE to help you improve the quality of your source code. We have C++ audits and metrics. If you're using C++ Builder from the past and you're still building Windows applications with our VCL or Visual Component Library, we've added styles so that you can have modern and changeable looks to the user interface. And you can still use the standard Windows styles and themes as well. You can connect to all the databases you need to connect to. We've added ODBC support in our DB Express technology as well, and lots of new tools to help you get the job done. First, for building native applications, we have our high-speed compilers, building applications for Windows and Macintosh. It's still component-based, event-driven components, event-driven programming, full access to databases, and again, the high-speed native code performance of the C++ compiler. With FireMonkey, you can build next-generation business applications, both in high definition. You might say 2D, but we always talk about these days high-definition television. Why wouldn't you want to have high-definition user interfaces as well? And 3D, if you want to take advantage of 3D effects and 3D animations and other things to improve even more the look of your application, then you can use FireMonkey. All you have to have in that case is a GPU chip that has at least DirectX 9 or later. And we'll talk more about that in the demos as well. You still have full high-speed native code compilation using the FireMonkey business application platform. You can still connect to databases like you would if you were on Windows only, and it works across Windows and Macintosh. You have a full set of user interface controls. You can connect your data to your user interface using a technology we call LiveBindings. All your user interface are vector drawn. They're rendered at runtime using the underlying graphics hardware. So you have great look, not only with styles, but scalability, and it all looks beautiful. You'll see that in some of the demos as well. You can move objects and animate properties over time. So you can use animations to do pulsing effects or movement and other things of objects as part of your user interface. Or you can change, for example, the color highlight properties over time. You'll see some example of animations. Also, we have a whole set of more than 50 effects that you can use on user interface elements, things like glow effects, reflection of the user interface. So all sorts of effects, dissolves, transitions. Think Photoshop for your user interface. All the things, dissolves, all of those effects that are available. We'll see some of those in action. And again, you connect to SQL databases, and if we don't have a SQL driver for your database, then you can use ODBC on Windows at least. You can build multi-tier applications in C++ Builder, build web services, or you can connect to web services wherever they might be, either through SOAP or RESTful web services. And we have our own DataSnap technology for building multi-tier. And again, building Windows and Mac, great-looking Windows and Mac applications with one set of code. You can connect to Amazon EC2 and Amazon S3 cloud storage and services. You can also connect to Microsoft Azure. We have a cold cloud API that you can use in your applications to start moving into cloud computing if that's a requirement for cloud storage and cloud application development. And the great thing is you only have to know one thing. It's one programming language, C++, one tool set, C++ Builder XE2, one business application platform called FireMonkey, one programming model. It's event-driven, drag-and-drop components. People are still, reconnect your phone by redialing. That's for some people who are saying they still couldn't hear. One programming model, it's event-driven, component-based, drag-and-drop components. And again, it's one project. Just change the target platform. You'll see that in the demos as well. Again, FireMonkey for building rich business applications. It's not a managed runtime. It's all native code. It's not HTML. It's not Flash or anything else. It is a runtime rendering system, and you build the code, and FireMonkey does the work. You recompile for the different platforms. So on Windows, we use DirectX, Direct2D, and Direct3D to do the rendering. On Macintosh, we use OpenGL and the Apple Core Graphics library for 2D and OpenGL for 3D. So again, one programming model. Depending on the platform you choose to build your application for, it's the same set of source code, the same components. It will build the right things. There's a project type. You just say, I want to build a C++ project of a certain type, and then I can build and set the platforms for it. As far as handling multi-platform issues, we do some of that in the components. We also do that in the runtime. There are some things to think about if you're a developer. There's no registry on Macintosh, so you should use something like INI files, for example. But we do have a runtime structure called TOS version that you can use to test what platform you're running at runtime, what's available, but you can also use conditional defines at compile time. You'll have to think about file volumes and paths. You know, Macintosh doesn't have a volume letter, and the path names have forward slashes in them. And of course, in Windows, it's backslashes, and there's a volume label or letter. On Windows, it's DLLs. On Macintosh, it's dilibs. So if you're building DLLs as part of your application, C++ Builder XE2 takes care of that for you. If you say you want to build a DLL and you're targeting Windows, it'll build a DLL. If you say that the target is Macintosh, it'll build a dilib for you. For debugging, we can debug Windows apps. We can debug remote Windows applications, Windows Server applications. We can also debug on the Macintosh, and I'll show you that. And then if there's any operating system and hardware specific things you want to do that are different between Windows and Mac, you can always get to the operating system even when you're building FireMonkey applications. You don't have to worry about that you're blocked off. There's still operating system interfaces. There's still hardware interfaces that you can call on each of the platforms. Of course, that code would then be specific to each Windows and Macintosh target that you're building. You can ifdef it, or again, use TOS version structure. So that's just a quick overview of what's available in C++ Builder XE2. Let me switch and share my desktop now, and let's go and do that. And there, and I'm sharing my desktop. So let me move a couple things around here. Let me close a couple things here as well. Let's not change that, and let's go and do this here. Oh, I wanted to close that. All right. So I'm going to bring up our IDE for C++ Builder. In this case, it's our RAD Studio product, which includes C++ Builder XE2 and Delphi XE2. What I'm running on, so you'll understand the environment here, is I've got my Macintosh. I'm using a MacBook Pro. It's got 8 gigabytes of memory, 4 cores, and it is, and I'm running Mac OS 10.6.8 Snow Leopard. I haven't moved up to Lion yet, and then Mountain Lion is coming soon. And in there, I'm running something we call our platform assistant, and I run that on the Macintosh so our IDE can talk to the Macintosh for debugging and deployment of the applications. So we run the PA server here, and it listens on a port. And then over on the other side, I've got my Windows IDE. And the Windows IDE lets me do my building, do my debugging on Windows, and I can also use the IDE to do my builds for Macintosh and deploy them through that platform assistant and do debugging as well from my Windows IDE targeting the Macintosh. So Windows IDE, my Windows operating system is Windows 7 64-bit. It's running as a guest operating system. I'm using VMware Fusion for the Macintosh that runs on the Macintosh side that lets me host the Windows. Some people use Parallels or other systems, but VMware Fusion for the Mac works very nicely for my purposes. Also gives me support for the graphics processing unit and graphics acceleration. So let's just open up a sample program here. This is our controls demo written in C++ Builder. And this is an example of showing some of the user interface components that are available in FireMonkey. Here's our structure window, our object inspector. Here's our component palette. This is where I do the design. I can switch to the source code. Here's my C++ source code, which is basically going to have event handlers for clicking on a menu item, for clicking on a button, for doing things. The user interface, I do the design of my application. Over here in the project window, I have target platforms, and here I can set up targets for 32-bit Windows and for Macintosh. So we'll start with the Windows version, and then we'll switch and show how easy it is to, say, now build it for Macintosh. So let's just run this application to take a look at some of the FireMonkey controls and a few things about FireMonkey development. So here's a set of user interface controls. We've got our tab notebook. We can switch through the different controls. It's got all the usual things, you know, an edit box. Notice a little highlight effect around the box when it's focused. We've got buttons, list boxes, track bars, status bars, scroll bars, either wide or narrow, list box with items in it, buttons, call-out panels, and so on. Here's a button inside of an expander. We've got these angle buttons that you can play with. Again, a track bar. Here's one that's numbers. It only takes numbers, and as we drag the mouse right and left, it'll change the value. Here's a button with a glow effect around it. We've got calendars, all the usual things you'd expect to see. Here's the idea of a 3D look and feel where we can change the rotation angle of user interface components. So here's my edit box, this here, for example, and it still works. We can change the opacity. We can change the layers. So we've got a circle with a gradient fill behind it. We can change the opacity of the user interface components. Or transparency, the property is called opacity. And so in FireMonkey, all the components are rendered using the graphics system that's linked in as part of FireMonkey. So in this case on Windows, I'm using in this case Direct 2D and Direct 3D or DirectX to do the rendering. So you could use opacity, for example, to bring forward parts of your user interface. Now, in Windows programming, we'd make something either visible or invisible, but FireMonkey gives us lots more control. It gives us X, Y, and Z if we're doing 3D positional, and also X, Y, and Z, in this case, two-dimensional components to do rotation. Now, trees or list boxes can not only contain text, but they can contain other kinds of components. For example, text and images. Here's a list box item. This is a list box item that actually has an edit box and a button inside of it. Here's a button. And the way FireMonkey allows you to do this is any component can contain other components. You composite your components just by parenting them inside the user interface. Here's a tree view with items and so on. You can also scale the user interface. Since it's all vector graphics drawn, notice all I'm changing is I'm changing a track bar at the bottom, and it's telling the form, this is a scaled layout form, to scale everything that's on it. So we get this smooth view so that if I'm running in different resolutions or on different desktops with different resolutions, then it'll still look great. And that's your choice in how you do design. Now let's go back and look at the design. Here's the scaled root, which has a tab control. So there's that tab control inside of a layout. And let's go back to the design. So here's the tab control inside of a layout, and this is another layout that's inside of that holds that control. And we simply set the scale factor and scale the application over time by dragging and dropping that track bar. So here's the T track bar. If we look at the on change, it just says set the X and Y of the control root scale property to be the position or value from the track bar, and it does that in percentages from 0 to beyond 100 to 200 and so on. So just as you might do in a graphics rendering system by scaling everything, FireMonkey has that built in as well. Now, if I want to build for Macintosh, all I have to do is set the Macintosh profile. I do that by saying add platform if I only had a Windows target, and say add OS 10, for example, OS X is there. The only other thing I have to do is I'll create a profile which allows me to specify what's the target platform of the operating system, what's the IP address of the host name. It might be a remote Macintosh, it might be a Mac Mini, it might be some other Macintosh somewhere on the network, port number to communicate to that platform assistant, and the password. And then here, any other additional files that need to be included to make my application run on the Macintosh, any dynamic libraries, for example. So now that I've got the Macintosh target built, and I've got my platform assistant running over here on the Macintosh, I can go and run the application. So it'll now build a Macintosh version, and when it's completed, it will deploy. It says deploying now. Oh, okay, let me do this. Socket error. Let's see what happened. Oh, I know why. It's because the network I'm on. So let me go find the IP address of my, let's bring up another terminal window. And let's put IP address, IF config. All right, and my IP address is, let's see, where are you? It's because I'm on my home network instead of on the work network here. So let's look, it's 192, oh, here it is, 192.159. Okay, so let me copy that, 192.168. Oh, did I? Oh, I did. Oh, you know why? That's why. You're right, Anders. Anders told me a reminder. I forgot to start the platform assistant, so it was actually working all along. Thanks, Anders. Let's hit run again. So Embarcadero was saying it couldn't talk to the platform assistant. So now if I switch back, here's my application running on a Macintosh. And again, it's fully scalable. So there on a Macintosh, I can scale it up and down a percentage. If I wanted to take and look at the different controls, we've got all that. Here's the angle buttons working and so on, right? So there, I'm on the Macintosh. Here's my menu. All FireMonkey applications can have a style. So let's go and choose the, let's see, let's choose a Macintosh Mac style, for example, which is probably the default. Yeah, I had it set for default, so it already was Macintosh. But if I want some other style, like maybe a dark style. So you can have your own styles. You can use FireMonkey and the ID to create a style as well. And you can load styles either from the file system or you can link them into your application as well. So here's a different style. Notice we get different glow effects when we're over the buttons and so on. So fully styled. Now, one thing about Macintosh applications, the default is to have your menu appear in the Macintosh menu. But if for some reason you want your users to look at the application window for the menu, we have an option here called Use OS Menu. I'll turn that off and rerun the application and switch back to the Macintosh and see that that now the menu is inside of the application window. So it's your choice how you want to do it. Again, the default is the default for, here's Ruby Graphite. The default is the default for the operating system. And that, so OS menu is turned on true by default. So let's look, that's not my favorite. Let's go back to maybe a Mac Blue style, for example. And so again, you can have whatever look you want, and inside the ID you can create your own styles. You can change the style just by choosing a component and right mouse clicking and say, let's edit the custom style. Now a button has a certain style. It's a rectangle. It's got a glow, might have an inner glow effect. I could add other effects to the button in the style and then save that as a new style or change the default style so that when the application runs, it'll have the style that you want. So color stylings, highlight stylings, glow effects, and so on. Now, let me bring up another application. This one is a 3D application, and if you know iTunes and other systems like that, there's this application called CoverFlow, which is a nice, smooth, flowing flipping of covers of albums, music albums, for example. We've done the similar thing here with what we call FireFlow built in FireMonkey. We've got a viewport 3D that surrounds everything, and then we've got a dialog box that it is a cross-platform open dialog to select pictures, and we have this other component called a layout 3D, and that's where we're going to put our pictures inside. And then we've got a bunch of code which is going to do the processing of reaching through the directory. So inside of the runtime library, we have a directory object that you can point to, and you can then use files and treat that directory or the file system as an object and go through the files in a directory and access the files, set the different heights and widths, color, transparency, and so on for each image. Let's take a look and see what this looks like at runtime. Let's go in and select some pictures. And so we've got these flowers here, and so here's the, and beautiful koalas. I can use the track bar to move through as well. What's happening here is we're loading up the images that we find in a directory using that open file dialog, and then we're displaying them into this flow, and the flow has the background pictures being pushed into the back, pushed in the Z-axis, which is positive away from the screen, negative towards you out of the screen, and angled at 70 degrees, and that's just a setting. And then as we select a picture, we bring it forward or negative Z-axis and zoom it up so it comes closer to the top. And then as we select other ones, notice the animation. Now, animation in FireMonkey is to animate properties. So in this case, I'm animating the X, Y, and Z position and the rotation angle of each of the images. So this one moves forward while I animate all the other images to move in some fashion, either move left and right, like the underneath pictures, or to come forward and then go behind and move at a 70-degree angle. So animations in FireMonkey are done using animations. So if I switch to the form view, we have a palette down here of all sorts of effects and animations. So the animations are to animate types of values, and these values can be published properties, for example, the height. One way you know is if a property can be animated is you'll see this little film strip icon, which is over here in the object inspector. So I can animate the height, I can animate the depth. If I look at position, X, Y, and Z, I can animate those values. Those are floating point values. I can animate rotation angles and so on. I can also animate color properties, gradient properties, anything that's floating point, either single or double precision. A rectangle, I can animate a bitmap. I can animate a path. I can take an object and move it along some predefined path as well. And all of that is done either in settings in the objects or in code. You can always do everything in code. And for effects, there are all sorts of effects again, and you can drop effects down. For example, if I wanted a glow effect on this button, so down here I've got a button, and if I wanted to put a special glow effect on that button, we'll just take the glow effect, associate it with the button, and I could change the color of the effect. Let's give it a glow. And notice now there's a golden glow around our button. We can enable it or disable it. And we can also set a trigger, for example, is it mouse over? So maybe we only want to have the glow effect happen when we have the mouse over that button. So let's go and rerun our FireFlow again. And now when I hover over it, notice it has a glow effect, right? So again, enhancing the user interface to give the user feedback, yeah, that's something you can click on. And this works, all the effects and all the animations work, whether it's a Windows or a Macintosh. Again, I just rebuild, click Run, or debug for that matter. And again, if I debug from my Windows ID to my Macintosh, the platform assistant is the thing that's sending back and forth the debug commands. So let's go and run FireFlow, and now notice I've got the glow effect again happening, and I've got pictures here that I can load. I think this is the Japan. Oh no, here's my pictures of nice landscapes and so on from around the world. And again, it's the exact same set of code, now doing a 3D operation with that glow effect that I put over the button. And that glow effect, and of course, it's running on Macintosh. That was just a glow effect connected to the button. No lines of code written. I just set the object inspector to be triggered when I do a mouse over it, right? So one set of source code for Windows and Macintosh. Now let me bring up a couple more examples real quick, and then we'll get to Q&A as well. This one is a couple programs that Anders, who works on my team, wrote. This is a math visualization, three-dimensional application. It's got a 3D form. And in the 3D form, it's got a control panel where I can choose different trigonometric or math functions. Then I've got some controls to do some zooming and rotating. And what's going to happen under the covers is for each of these functions that you choose, he's going to calculate the points of triangles. He's going to calculate the color that he wants to texture for the resulting value based on a range of values. And it's going to send all of those triangles off to the GPU, and the GPU is going to do the rendering. On Windows, it's going to use Direct3D to talk through the GPU, and on Macintosh, it's going to use OpenGL, in this case, of 3D. So let's run it first on Windows. Let's zoom it up, and let's do the first function. So here's a nice 3D trig function, the sine of x squared plus z squared divided by x squared z squared. So as x and z are 0, then we get infinite value, and then Anders is setting that infinite value and setting the color for the ranges of the resulting value y. And I can use this control panel to zoom in and out. All of this code is available via his blog, and that's blogs.embarcadero.com/AO, the letters AO for Anders Olsen. So all this code is available for you to have, and you can see, again, how FireMonkey works. Here's another kind of three-dimensional display of points. So it's just calculating. Then we look at the backside. Here's these grids. These are just there for orientation of the values of x, y, and z. Now, again, this exact same code is using a mesh component. So into the layout, we've got a mesh, and inside of the mesh, in his code, he's just filling up low-level data structures. Here's the source code for each of the functions. He's got epsilon, which is a value that's close enough to 0. If we get the, if the result is infinite or not, we have to do something with it. He's calculating the points on the XZ plane for the triangles. He's calculating the Y value for the function that was chosen. He then sets the points in this data structure inside of the mesh called the vertex buffer, which are the vertices of the points. He maps the texture colors based on the values, and then he maps the triangles into the mesh, the index buffer of the points that make up the triangle. And then all those triangles are sent off to the GPU, and the GPU renders them. He sets the texture based on the values for the material on the mesh, and that's how the colors get there. Now again, this works on the Macintosh, same code. Let's go and add a platform. Here's the Mac OS X, and we'll go and build it for the Macintosh. And let's run it. So it's linked, and then we'll say run. And again, it will do the build, and we can switch over to our Macintosh. And here's that same application with that beautiful graph running, rotating it, zooming it around, looking at the bottom, zooming in on the data points. Again, all of this is single set of source code running without any FDEFs on Windows and Macintosh. One last quick demo. Again, we can do all the database access and other things we need to do. Let me load up, let's see, one quick example that shows this version information and how you might use it if you want to do some special runtime testing of your application. So here, I'm just going to output the value of my operating system version, the name of the operating system. I'm going to output the major, minor, build numbers, service pack values, and which platform the application is running on, what kind of architecture it's running on. And this is, again, using this OS version structure and getting the architecture information, getting the build major and minor number information, and testing which platform I'm running on. So let's build this first for Windows 32. And here I get the information. It says there's the name. It's called Windows 7 Service Pack 1. OS name is Windows 7. The architecture, it's running on 64-bit Intel architecture, but I'm building a 32-bit application. It's major 6. I'm running 6.1 is the version, Service Pack 1. And again, the target platform is Windows 32. And that just comes from down here. It takes, what I do is I take the size of a pointer in bytes. So a pointer is defined just as for this case, a point to an integer. And so I multiply that by 8. So that gives me my Win32. And then if I run this on Macintosh as well, it should say that it's now running on Macintosh operating system. And click the button, and it says Mac OS 10, build 10-6, Service Pack 8, 10.6.8, running again on a 64-bit Intel processor. Target platform is OS X, and the size of a pointer is 32 bits again, so OS 32. We're still using our 32-bit compiler. We're working on a 64-bit compiler in the future for C++ Builder. So that's a way, without having to do ifdeps, that I can use this TOS version platform information to do any runtime dispatching of my application. Of course, I can put ifdeps inside of the code as well. All right, one last demo. There's so many things to demo, and we have all the links to lots of our demos are available on SourceForge. You look for RAD Studio demos on SourceForge. We have a whole repository up there. Here's one last one that Anders also did. It's a wave interaction demo. In this case, he's going to calculate meshes on the fly based on wave interaction. So here we've got a wave. It's like dropping a pebble in a water vat in one corner. We can change the wavelength. Now this, because of WebEx, is probably not going to look, it's going to look a little choppy because WebEx is just grabbing a few frames at a time, and I can change the velocity as well. If I put another wave in at another point and maybe turn on all 4 waves, then I start seeing, you know, something pretty exotic. And then I can use the mouse to rotate around as well and look at the bottom, the right, and the left. And again, in this case, he's calculating the meshes in real time, sending them off to the GPU, and eventually the GPU fan's going to come on because it's calculating and displaying so many triangles all along the way. And again, this same application runs on Windows and on Macintosh. So if we just go and say, let's add platform. Oh, my fan just went on, so the GPU was working pretty hard. Let's go and run now this same 3D mesh where the, let's go and let's do a build, sorry. Let's do a build for the first time. Let's go and build the wave. First time because I just added the platform, and let's go and run it. And now it will send the application over. And here I've got the same wave interaction with a Macintosh look and feel, and I can change the wavelength and the velocity and the amplitude of these wave interactions. The amplitude really makes it fun. And again, I've got full support for using the mouse to rotate it around and look at all the different aspects. So again, here's a 3D graphic scientific application. Again, it's the same code. Let's go and look at the source code real quick. Main form source code. Here he's just calculating the amplitude. He's generating the points based on the wave interactions, and then he's setting the points in the vertex buffer, mapping the colors based on the values of the wave interactions, telling the mesh where the triangles are by the sets of points. So here's the different points for the triangles. And then he just sets the material of the mesh. And again, FireMonkey, underneath the covers, does all the work to send the data for the mesh into the GPU and let the GPU render it. So lots of different demos are available. Let's just look at one last one. This is just a 2D animation that shows different animations that are available in FireMonkey. And let's run this. Oh, it's running on Macintosh, so let's go over to the Macintosh again. And, oh, okay, that one I'm not going to run there. Let's go and, this is the first time I ran this one. Let's just test it first on the Windows. What I'll show you is here's animating the rotation angle of a circle and with a gradient fill, and notice the gradient fill goes with it. Here's some path animation where this button is following some path. Here's these little animated indicators, and then we're using float animation on the opacity property with a gradient fill, and here's a color fill happening as well. So again, you can control all of this just by setting the duration of the animation. You can also set a trigger for the animation if you want. And again, we're animating a type, in this case animating, this is animating color, so it's changing the start. It's going from the start and stop value over a period of time, a duration of 1 second or 2 seconds or 5 seconds and so on. You can do all of this in the object inspector. You can do it in code as well. You can call the float animation function, set the delay time as a parameter. So anything you can do. You also have choice over the animations, whether they're bounce, circular, cubic, elastic, linear, quadratic. So how the animation flows, you can set the choice there. In this case, it was set to exponential. All right. So with that, I'm going to stop sharing my desktop. And let's see, there we go. And come back to the slides. And just to summarize, and then we'll get to questions as well. C++ Builder XE2 lets you build applications for Windows and Macintosh, one set of source code, with full high-resolution user interfaces you saw with full scalable vector graphics for the UI components, with 3D rendering of your user interface, and scientific with the mesh. You can build custom meshes. We also have a component called T-Model 3D, which allows you to load into your user interface Collada DAE files, Maya OBJ files, ASC files, or ASCII scene export files. We also have some samples that show you how to import 3D Studio files as well. So again, with full database access and full support for the operating system underlying. FireMonkey for doing cross-platform development. You write to FireMonkey components, use FireMonkey components. You compile and run on the different platforms. It uses the native rendering systems that are available on the platforms. On Windows, that's DirectX. On Macintosh, it's the Core Graphics 2D library, and it's OpenGL for 3D. And again, all that's under the covers. You don't have to think about it. You write to FireMonkey, you do your C++ programming, use the user interface components, and then you can build all the applications you need to build for Windows and Mac from the